A diesel engine is an internal combustion engine that operates on diesel fuel. It's similar in many ways to a gasoline, petrol, engine but has some critical differences, primarily in the way the air-fuel mixture is ignited. Here's a basic overview of how a diesel engine works. 4-stroke cycle. Like gasoline engines, many diesel engines operate on a 4-stroke cycle. Intake stroke. 1. The intake valve opens. 2. The piston moves downward, drawing in only air, unlike gasoline engines, where air and fuel are mixed before entering the cylinder. Compression stroke. 1. Both the intake and exhaust valves are closed. 2. The piston moves upward, compressing the air significantly. 2. Due to this high compression, the temperature of the air rises. Power, combustion, stroke. 1. Just as the piston reaches nearly the top of its compression stroke, near top dead center, diesel fuel is injected directly into the highly compressed air in the cylinder via a fuel injector. 2. The heat of the compressed air ignites the diesel fuel. 2. No spark plug is required. 3. The combustion forces the piston downward, providing power to the crankshaft and subsequently to the vehicle's wheels. Exhaust stroke. 1. The exhaust valve opens. 2. The piston moves upward again, pushing out the burned gases from the cylinder and out of the engine via the exhaust system. Key differences between diesel and gasoline engines. Ignition method. Diesel engines use compression ignition, where the fuel ignites due to the high temperature of compressed air. Gasoline engines use spark ignition with a spark plug. Air-fuel mixture. In gasoline engines, air and fuel are typically mixed before entering the combustion chamber. In diesel engines, only air is inducted during the intake stroke, and fuel is directly injected into the combustion chamber. Compression ratio. Diesel engines have a much higher compression ratio, often 14:1 to 25:1, than gasoline engines. This high compression results in higher combustion efficiency and more torque but also requires engine components to be sturdier. Fuel efficiency. Due to the higher compression ratio and the energy-rich nature of diesel fuel, diesel engines are generally more fuel efficient than gasoline engines. Emissions. Diesel engines tend to produce less carbon dioxide, CO2, than gasoline engines but can produce more nitrogen oxides, NOx, and particulates, which is why many modern diesel vehicles are equipped with special exhaust treatment systems. Advancements. Modern diesel engines have seen significant advancements in terms of efficiency, emissions control, and performance. They often employ 1. Turbocharging, to force more air into the cylinders, increasing power and efficiency. 2. Common rail direct injection, a system where fuel is supplied to injectors from a common rail, allowing for better fuel atomization and more precise injection timings. 3. Exhaust treatment systems, like diesel particulate filters, DPF, and selective catalytic reduction, SCR, systems to reduce harmful emissions. In essence, diesel engines convert the chemical energy in diesel fuel into mechanical energy through a series of controlled explosions inside cylinders, with the distinguishing feature being compression ignition.